करने जा रहे हैं इंटीग्रेशन बाय पार्शियल फ्रैक्शंस। पार्शियल फ्रैक्शन मीन्स स्मॉल fractions, small parts of equation. There are 3 or 4 types of partial fractions. The first type of partial fractions are of the type px plus q upon x minus e into x minus b. Any question which is of the form of px plus q upon x minus a into x minus b or into x minus c or any another linear factor, the degree of numerator must be less than that of the denominator. Then it can be written as capital A upon first linear factor plus capital B upon second linear factor. If there is also another linear factor, then that can be written as capital C upon x minus c. And after finding these two values of A and B, we can find the integration of the right handed side very easily. So this is the procedure, this is the method, this is the first type of partial fractions by virtue of which we can find the integrations of such type of questions. So now let us discuss the first type of partial fractions with the applications of the partial fractions. Now question number 2, the integration of the first type of partial fractions. Question is integrate x upon x minus 1, x minus 2, x minus 3. These are the linear factors and numerator is also linear. Power of degree of numerator is less than that of the denominator. It may be linear, it may be constant, it may be quadratic in this case. In order to find the first type of partial fractions, degree of the denominator must be greater than that of the numerator, and which is here. Here degree is 1 and here is 3. So let x upon x minus 1 into x minus 2 into x minus 3 is equal to a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. This implies x upon x minus 1 into x minus 2 into x minus 3. Taking LCM to the right hand side, we get x minus 1, x minus 2 into x minus 3. Now, dividing LCM by denominator, we get x minus 2 into x minus 3. We get a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. After that, cutting with LCM by LCM. Cutting denominator by denominator, we get x is equal to a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. In order to integrate this, we have to find the value of a, b and c. Value of a can be calculated putting x is equal to 1 to these equations. If we put x is equal to 1, the value of this will be 0, this will be 0, and we can find the value of A. Similarly, value of B can be calculated by putting x is equal to 2 here, and value of C can be calculated by putting x is equal to 3. Let us find the value of A, B and C one by one by putting x is equal to 1, x is equal to 2 and x is equal to 3 in these solutions. Now putting x is equal to 1, we get 1 is equal to A into 1 minus 2, 1 minus 3 plus B into 1 minus 1 into 1 minus 3 plus C into 1 minus 1 and 1 minus 2. We get 1 is equal to A into minus 1 into minus 2 plus B into 0 plus C into 0. Because 1 minus 1 is 0 and 1 minus 1 is 0, it makes everything 0. 1 is equal to 2A plus 0 plus 0. This implies 2A is equal to 1 and if either A is equal to 1 by 2. Now in order to find the value of B, putting x is equal to again putting x is equal to 2, we get 1 x is come to 2 is equal to A into 2 minus 2 into 2 minus 3 plus B into 2 minus 1 into 2 minus 3 plus C into 2 minus 1 into 2 minus 2. That becomes 2 is equal to A into 0 plus B into 1 minus 1 and plus C into 0. It becomes 2 into 0 minus B plus 0. Therefore, minus B is equal to 2 if either V is equal to minus 2. This is the value of the second constant of this partial fraction. A is equal to 1 by 2 and B is equal to minus 2. Again putting x is equal to 2, we get 2 is equal to A into 2 minus 2 into 2 minus 3 plus B into 2 minus 2, 2 minus 1 into 2 minus 3 plus C into 2 minus 1 into 2 minus 2, we get 2 is equal to A into 0, 2 minus 2 is 0 which makes everything 0 plus B into 1 into minus 1 plus C into 0. That is equal to 2 is equal to 0 minus B plus 0 if either minus B is equal to 2, if either B is equal to minus 2. In this way, we have find the value of A, that is 1 by 2, and value of B, that is minus 2 of this question. Now let us find the value of capital C, and that can be calculated by putting x is equal to 3. Now putting x is equal to 3, we get 3 is equal to capital A into 3 minus 2 into 3 minus 3 plus capital B into 3 minus 1 into 3 minus 3 plus capital C into 3 minus 1, 3 minus 2. We get 3 is equal to A into 3 minus 2, that is 1 into 0 plus B into 2 into 0 plus C into 2 into plus 1. That is 3 is equal to 0 plus 0 plus 2C. 2C is equal to 3. This implies C is equal to 3 by 2. Now we have find all the three values, capital A, capital B and capital C of this partial fractions. Now putting these values, we get the partial fractions of the given question. Now these partial fractions becomes, after putting the value of A 1 by 2, value of B minus 2 and value of C, this question becomes this. These are the small fractions of this question. Therefore, integration of x upon x minus 1, x minus 2, x minus 3 into dx is equal to integration of 1 by 2 upon x minus 1 plus minus 2 upon x minus 2 plus 3 by 2 upon x minus 3 into dx. And that is equal to 1 by 2 into log of x minus 1 modulus. Because integration of 1 upon x minus 1 is log of x minus 1 modulus. Minus 2 into log of x minus 2 modulus plus 3 by 2 into log of x minus 3 modulus plus constant of integration c. This is the answer of this question. Therefore, integration of x upon x minus 1, x minus 2 and x minus 3 into dx is equal to this. This is the procedure to find the integrations of the first type of partial fractions. You can find the value of a, b or c, and putting the value we get the fractions, and after taking the integration we get the answers. That's all. Exercise 7.5, question number 3. This question is of the first type of a partial fraction. The question is integrate 3x minus 1 upon x minus 1, x minus 2, x minus 3 into dx. Before finding the integration of these questions, we have to divide these questions in small parts, small partial fractions. So let 1 upon 3x minus 1 upon x minus 1, x minus 2 into x minus 3 is equal to first type of partial fractions, a upon first linear factor plus b upon second linear factor plus c upon third linear factor. Now again 3x minus 1 upon x minus 1, x minus 2 into x minus 3 is equal to taking LCM of the right hand side, that is x minus 1 into x minus 2 into x minus 3. After taking LCM, dividing LCM by denominator of this first, we get x minus 2 into x minus 3 and multiplying it by capital A, x minus 2 into x minus 3. Similarly, plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2, and cutting denominator by LCM by LCM. Denominator से denominator cancel because they are same. We get 3x minus 1 is equal to capital A into x minus 2 into x minus 3 plus capital B into x minus 1 into x minus 3 plus capital C into x minus 1 x minus 2. Now we have to find the value of A, B and C, and after putting the value of A, B and C, we will get the partial fraction of these required questions, and we can find then the integration of this right hand side very easily. What is the procedure to find the value of A, B and C of such type of partial fraction? In order to find the value of A, we have to put in these equations x is equal to 1. If we put x is equal to 1, then left hand side will be equal to 3 into 1 minus 1 is equal to capital A into 1 minus 2 into 1 minus 3 plus capital B into 0. After putting x is equal to 1 here, we will get B into 0 and also C into 0, because we are putting x is equal to 1 and x is equal to 1 here and here. X minus 1 are the factors in the coefficient of B and C. Therefore, it becomes 0, and B will get the value of A. Similarly, when we put x is equal to 2 here in these equations, the A into 0 and C into 0, and we will get the value of B. And after putting x is equal to 3 in these equations, we will get the value of C, because A into 0, B into 0 and C into something, and we will get the value of C very easily. And after putting the values of A, B and C, we will get the partial fraction of a first type. Now let us put x is equal to 1, x is equal to 2 and x is equal to 3 in order to find the value of capital A, capital B and capital C of these questions. Putting x is equal to 1. Putting x is equal to 1, we get 3 into 1 minus 1 is equal to capital A into 1 minus 2, 1 minus 3 plus capital B into 1 minus 1 into 1 minus 3 plus capital C into 1 minus 1 into 1 minus 2. This implies that is 3 minus 1, that is 2, is equal to A into minus 1 into minus 2 plus B into 0 plus C into 0. And therefore, it becomes 2 is equal to 2A. B into 0, 0 plus 0. 2A is equal to 2 and hence value of A is equal to 1. This implies 2A is equal to 2 and therefore capital A is equal to 1. This is the value of the first constant which we have to find the partial fraction of this question. Similarly, putting x is equal to 2 and x is equal to 3, we will get the value of B and C. Putting x is equal to 1, we get 3 into 1 minus 1 is equal to A into 1 minus 2 into 1 minus 3 plus B into 1 minus 1 into 1 minus 3 plus C into 1 minus 1 into 1 minus 2. We get 3 minus 1, that is 2, is equal to A into minus 1 into minus 2 plus V into 0 plus C into 0. And after this, we get 2A is equal to 2. This implies A is equal to 1. We have find the value of the first constant A, which is required to find the partial fractions. Similarly, putting x is equal to 2 and x is equal to 3 respectively, we will get the value of B and C. Now putting x is equal to 2, we get 3 into 2 minus 1 is equal to a into 2 minus 2 into 2 minus 3 plus b into 2 minus 1 into 2 minus 3 plus c into 2 minus 1 into 2 minus 2. We get 6 minus 1 is equal to a into 0 because 2 minus 2 is 0, then it becomes 0 plus b into 1 into minus 1 plus c into 0 because this 2 minus 2 becomes 0. 5 is equal to 0 and minus b plus 0. This implies minus b is equal to 5 if either b is equal to minus 5. In this way, we have find the value of second constant b for this partial fractions. And again putting x is equal to 3, we get 3 into 3 minus 1 is equal to a into 3 minus 2 into 3 minus 3 plus b into 3 minus 1 into 3 minus 3 plus c into 3 minus 1 into 3 minus 2. 3 into 3 minus 1 is equal to a into 3 minus 2 into 3 minus 3 plus b into 3 minus 1 into 3 minus 3 plus c into 3 minus 1 into 3 minus 2. And it becomes 9 minus 1 is equal to a into 1 into 0, 3 minus 3 is 0 plus b into 2 into 0 plus c into 2 into 1. And after this, we get 8 is equal to a into 0, that is 0 plus b into 0, that is 0 plus 2c. And therefore 8 is equal to 2c. This implies 2c is equal to 8 and hence c is equal to 4 after cutting 2 by 8. In this way, we can find the value of a, b and c for the first type of partial fractions. Now after putting the value of a, b and c, we get 1 upon x minus 1 plus minus 5 upon x minus 2 plus 4 upon x minus 3. Because value of a is 1, value of b is minus 5 and value of c is 4. Now this question converted into these simple fractions. We can find their integration very easily. Integration of 1 upon x minus 1 is log of x minus 1 modulus. Integration of 1 upon x minus 2 is log of x minus 2 modulus. And integration of 1 upon x minus 3 is log of x minus 3 modulus plus constant of integration c. Now integration of 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 into dx is equal to integration of these fractions x minus 2 plus 4 upon x minus 3 into dx. We can integrate the right hand side very easily and find the integration of these questions by first type of partial fractions. These are the partial fractions. That is equal to log of x minus 1 modulus minus 5 outside, log of x minus 2 modulus and plus 4 outside, log of x minus 3 modulus plus constant of integration c. This is the integration of these questions. That's all.